Newton's first law we already went over. What was it? Kaylin, tell me.
Object in motion stays in motion. Object at rest stays at rest. So acted upon by force.
Object in motion stays in motion. Object at rest stays at rest unless acted upon by an outside force. We talked about Newton's second law. It is the law that gives us the formula that says force is equal to mass times acceleration. It relates force and acceleration with mass. Newton's third law is the one that says for every action there's an equal and opposite reaction.
What's that off of? It's off in movie.
That's off
Okay, so the next thing you need to know are the four types of friction. What are the four types of friction? Sliding, rolling, static, and fluid. Rolling, sliding, static, and fluid.
Did it have to be in that order?
No, it doesn't matter what order. Static, sliding, rolling, and fluid. In no specific order. I think I said a different order every time I said it.
Yes, you did.
Rolling and static, sliding and fluid.
Rolling, static, sliding.
This guy right here is going for this.
So it'd be the RSS.
It's a little late now, though. I don't know if we'll switch classes.
Rolling, static, what else?
Rolling, static,
Switch out of band.
sliding, fluid.
Why you bend your
I could feel the hatred.
Keep the cheek band, Rachel.
Wait, why is fluid one?
Fluid friction.
Fluid friction?
What's that?
Like when you're in water or when you're in air, birds use fluid friction for flying.
Okay.
You use fluid friction when you're in water to swim. You push against it. It's friction. You push against it. Pushes you forward.
I love swimming.
No, don't let her in.
That was pretty slick, but
What did you
I am your mother.
I would have fell and face planted.
The fun is you have to get turned away. Yesterday they were selling Krispy Kreme donuts, and I think today I'm gonna buy it. Krispy Kreme donuts are the best donuts ever.
Birch donuts are nasty. Good if you go to like the store and they're coming off the conveyor belt and they're hot and fresh. Those are good. Otherwise, they're just like any other donut out there.
No.
Birch donuts are disgusting. They have
All right.
cereal and stuff.
Bring it in. Thank you. Describe the difference in balanced and unbalanced forces. Again, I don't want you restating the question on any of these, but especially this one, because this one's easy to do. Do not restate the question. I want you to explain it to me. I want you to write down everything you know about any of these questions. Because here's the deal. If I'm looking for one thing specifically, maybe you know it, but you only wrote one of the two things down that you knew, and you didn't write the right one. If you write it all down, and I find it in there, I will give you the points for it. But if you just write down one little thing, and it's not what I'm not specific enough, you'll miss the points. Yes. We'll describe the difference in balanced and unbalanced forces. So what does that question actually mean?
The difference between the two.
The difference between them. Okay, so what is the difference between them? Who can explain that? Like, what does balanced force mean? What do balanced forces mean? It's stable. It doesn't move. It stays in the same spot. So that means that all the forces that are acting on the object balance each other out. Therefore, the object has no motion. But an unbalanced force, or unbalanced forces, means that all these forces are pushing on an object and they don't balance each other out, and it causes the object to be in some sort of motion. So maybe there's two forces pushing on it, one from the left and one from the right, and the one on the right is pushing stronger, so the object actually moves towards the left
So one object has more.
because it's unbalanced forces.
So one object has more friction.
Not necessarily.
One weight.
But just the forces in general applying on it. One of those forces is greater than all the others, causing motion, so it's an unbalanced force. But if it's balanced, they all balance each other out, and the object doesn't move, it's at rest. So like the table sitting in front of you right now, is it moving?
No.
No,
It is
it's not going anywhere, because all the forces that are pushing on are balanced. Earth is pushing up on it, gravity is pushing down on it, those forces are balanced, and the table's not going anywhere.
What's something that's unbalanced? Something that's in motion?
These computers, when I push them,
So
gravity's pushing down on them, the table's pushing up on them, and I'm pushing that way. They're not balanced, so they're moving that way.
So can we put something that's in motion?
Something that is in motion is has unbalanced forces, yes. What is gravity? be careful with this question. I do not mean what is Earth's gravity. I mean explain to me what gravity is.
The force that acts upon you.
Close.
The action, the attraction between two or more objects.
The force or attraction between two objects.
So close.
Okay? Any two objects have gravity. They're attracted towards each other. What are two factors that affect the strength of gravity?
Distance and stuff. Mass.
Distance between the two objects and the mass of the two objects. The more massive objects are, or the closer distance between them, the greater the gravity. Now, on Earth, it's really hard for us to visually see this because there's only one gravity we get to see on Earth, and that is Earth's gravity. Nothing is as massive as our Earth that we deal with, therefore we can't see any other gravity. Okay? Right now, you and that desk are actually attracted to each other. You're being pulled towards each other, but Earth's gravity is stronger than that attraction, so it pulls both of you down and keeps you grounded and doesn't let you come together. All right. You will need to know the formula for momentum. Not that you won't need to know these. Guys, I need you to pay attention, please. You will need to know all three of these formulas, and the other formula is the momentum formula, which the formula for momentum, remember it's got the weird letter that doesn't actually appear in the word momentum, but we use it. Momentum is equal to mass times velocity. Momentum is equal to mass times velocity. If you'll forget, stop screwing that table around. If you're going to forget what those variables are, you might write them out in words instead of writing them and then forgetting and not knowing what they actually mean. So P means momentum, the M means mass, and the V means velocity.
Where's P?
On the smartboard. It started working again. And it stands for momentum. P stands for momentum. Mass and velocity. Over here, the force is equal to mass times acceleration. But here, mass times velocity is momentum. All right, the next thing you need to know is the difference between mass and weight. They are not the same thing, and you need to be able to tell me in words the difference between them. So who can tell me first what mass is? Let's start with the simple one. What is mass?
How much matter?
The amount of matter an object has. I knew what you meant. The amount of matter that an object has. How much stuff makes it up? Mass will not change based on any other factors. Now, mass can change. If you eat a cheeseburger, you are now made of the mass you had before plus the mass of that cheeseburger. And so your mass does change based on that kind of stuff. But overall, your mass does not change like if we go to a different area where gravity is different. So what is weight? What is weight? Who can tell me what weight is now? We know that mass is the amount of matter. What is weight? Trinity?
Like what something weighs?
It is what something weighs, but that's just restating the question.
Oh. I don't know.
So,
How
can you
much
describe
of
it
it
further?
The amount of gravity.
How much of it there is?
Not how much there is of it.
The amount of gravity you put on an object.
The force that is created by gravity pushing that mass downwards. So mass is the amount of matter an object contains. Weight is gravity's effect on that mass. Okay? Mass is how much matter an object contains. Weight is the effect that gravity has on that mass.
So I got that right?
I have so much gravity. Oh my.
Yeah. Wait, what is P? What does F stand for?
Force.
Wait, what did you say?
What does F stand for?
F is force. I thought you said that.
I think I'm being
Okay.
honest, but
Units that you're going to need to know. I've got them on a slide for you. I wrote down all the formulas you'll need to know, which you've already written because we just wrote the momentum formula, and those three are on the whiteboard. So these, hopefully you've already written all of these in your notes. Okay? If you haven't, you might go ahead and write them. The units is the next thing. There are 5 questions on here that simply ask you to tell me what the unit is for a certain variable. So if there's a question that says, what is the unit for mass? The unit we use for mass is kilograms. Side note, the reason this is on here, The reason I put this conversion on here is because there is a question on the quiz that gives you a mass in grams, and you will have to convert that to kilograms. You can simply move the decimal 3 places to the left to do that.
Oh, that's so easy.
Okay? If you're converting from grams to kilograms, you move the decimal 3 times to the left. 3 places to the left, that converts it to kilograms. Acceleration! You will need to know the formula, or the units, not formula, sorry, you will need to know the formula, but the units for acceleration, meters per second squared. Another unit that is a valid acceleration unit is newtons per kilogram. We get that from this formula right here. We divide force by mass, we divide newtons by a kilogram. So newtons per kilogram is a unit of acceleration. Units for force. Newton is the main unit that we use for force, but you can also use kilogram meter per second squared. Kilogram meter per second squared. That comes from this formula. When we multiply a kilogram, a mass, by an acceleration, a meter per second squared. Kilogram meter per second squared. That's a valid acceleration unit, or force unit, or you could say Newton. Either one will work.
Wait, so do we need all the units?
What?
Do we need all the units?
Question how?
5 of the questions on the quiz are about these units. And it would be best if you could tell me both units when there's 2 options.
Never mind.
So I would try to memorize this page.
Oh my gosh, I don't know if I can memorize it.
You have 3 days.
We already got it locked in.
Okay. Velocity, this is the same as speed, but the unit for that is meters per second. That's an old unit. You should already know that, but I put it on there just in case. And the unit for momentum. If we look at the momentum formula, we're multiplying a mass, which is a kilogram, by a velocity, which is a meter per second. So our unit for momentum is kilogram meter per second. You literally multiply them together. And that is the information you need for the front half of the test. In my opinion, that is the hardest as far as it's the most information to remember. Because the backside is problems using these 3 formulas. You're just solving these for these formulas.
I don't want to mess this up. So in the right corner,
Me
you know how you move 3? What is that called?
What is what called?
What is that called? That close. What are you doing with it?
You're converting from grams to kilograms. So that's the front half of the test. We are going to work as many sample problems as we can before the bell rings.